In this very short video, we will talk about the solid sport and mobile phase and stationary phase of paper chromatography. As far as the solid sport is concerned, as we have said earlier, that paper is used as a solid sport material in paper chromatography, and that paper is made up of cellulose. And the properties which are likely to affect separation process are the porosity of the paper, pore size, the thickness, and the metal contents with the paper. These cellulose papers can retain about 5 to 20% of water, based upon the fact that the major portion of this water is held via hydrogen bonding, and the remaining minor portion with other attractive forces. Because paper is made up of cellulose, and while paper manufacturing, different processes have been applied, and most of these hydroxyl groups may be converted into carbonyl and carboxyl groups. So water retention is based upon all these groups and their relative hydrogen bonding present in there. Other than simple cellulose, the solid sport may be transformed into ion exchange cellulose papers, where an ion exchanger like a cation exchanger or anion exchanger is incorporated into cellulose, okay, either by chemical reactions where the hydroxyl groups present in the cellulose are converted into like carboxyl groups or sulfonic acid groups or dialkyl amines. So a cation or anion exchanger sites are created. Second option is to blend that paper with some ion exchanger materials, and these blends may be up to 45% of the ion exchanger, like silica or alumina, etc. They can also be blended with cellulose while making these papers, and we can say that these are the modified form of the paper, which in turns will not remain as solid sport, rather they will have some mechanisms of separations involved there. So for a simple paper chromatography, simple cellulose will act as a solid sport, and it will be theoretically an inert material. As far as the mobile phase is concerned, so as we have stationary phase, that is water, which is entirely a polar substance, we have to choose a mobile phase which has different polarity than water, and to the extent which can separate the components. It may be compounds like phenol water system, phenol water ammonia, butanol water acetic acid, or butanol water pyridine. So these mixtures with their ratios are described here, and they are here to separate amino acids or fatty acids. And simply for sugars we have pyridine and ethyl acetate, and similarly water from chloroform and other mixtures, and for metal ions we have pyridine and water and butanol, HCl, and other ratios with their respect. These ratios are actually generated to obtain the desired polarity of the mobile phase. Various liquids that can be used as a mobile phase are listed here in increasing order of their polarity. Water is at the bottom, having highest dielectric constant 78.3. So these dielectric constants indicates the respective polarity of that very liquid. So hexane is at the top, having nonpolar characteristics, and similarly there are other liquids, aromatics, and then we have the acids, and then pyridine, and then acetone and ethanol and methanol and water. So mobile phase can be chosen from these or can be blended while choosing more than one liquids from the list along with some acid or base according to the requirement of separation.